Here we go again. This is Talking Digital Industries, the podcast for technologies and trends that drive industrial enterprises. And I'm your host, Chris Brow. Great that you could tune in again for our second episode, and I'm excited to discuss a technology that's changing the face of industry. It's called additive manufacturing. You've probably heard of the word 3D printing. This is set to disrupt the business world. Some even say this is going to kill traditional production models and supply chains. And I'm looking forward to learning more about how we might 3D print the future of industry. And I'm happy to have a real expert with me here today who can boost my understanding of this topic. Joining us is Dr. Karsten Heuser from Siemens Digital Industries. And at Siemens, he's also known as Mr. Additive. There he is, and there's the smile, because he leads the company's additive manufacturing activities. And here's what he has to say about today's topic. In 10 years, additive manufacturing will be everywhere, from consumer goods to industrial applications. First off, welcome, Karsten. Great that you could join us. How are you doing tonight?
Thank you. Thanks for inviting me to the podcast.
Great to have you on the show. We're going to start it off with things that our listeners might also be familiar with. For example, 3D selfies, 3D printed clothes, perfectly scaled statues like the first 3D printed bust of President Barack Obama back in 2014. 3D printed beef and mashed potatoes. That's something that's totally crazy. I could hardly imagine. And just a few weeks ago, the world's largest 3D printed house was completed in Dubai, measuring 9.5 meters in height and a floor area of 640 square meters. I mean, where is this going to? You know, the variety of 3D printed objects is growing, and some are a bit obscure. Some are really, really weird. Karsten, what was your favorite 3D printed object you've come across in the last few years? What was the most interesting?
Interesting question, Chris. What about this? The University of Maine worked with Ingersoll machine tools and printed an extremely large boat. First, you need a large printer. So the printer of a size of 30 times 7 times 4 meter in size, printing more than 200 kilo of material per hour.
That's the size of the printer?
That's the size of the printer.
Okay.
And now the boat itself is printed in 72 hours and is of a weight of 2 tons of material and more than 30 meters large.
So in comparison, what would you say would you normally need? Time-wise, to build a boat like that? You said 72 hours for the printer. What would you normally need?
Weeks, months.
Really?
So you need to assemble a lot of different parts. It's very expensive and it takes a really long time. You need to look up on YouTube. It's pretty cool. At the end, the full team of the university and Ingersoll, they're stepping into the boat and testing it on a real live test, and you will see this video on YouTube.
Wow, that sounds amazing. I'm going to check that out for sure. Now, that was something big. What else is there? What else did you come across?
I have something more, which is pretty tiny. It's only 5 millimeters in size. It's a printed whistle. You want to hear it?
Is that what you have in your hand right now?
I have it in my hand, and it actually works. Did you hear?
Amazing. I can hardly see it from here, actually.
Yeah, and actually, if you consider a whistle, you normally need to assemble it out of different parts. You need to have a sphere inside. And this is out of metal, printed by metal binder jet technology. It's printed in one part. And the sphere itself is printed inside of the whistle.
Wow. Okay. So we have something very interesting here from both ends of the bookcase, so to say, a very big boat and the tiny whistle you mentioned. But if we go back, maybe you can help me answer a few questions about how it all started. I mean, who invented 3D printing?
It's not pretty new. So it all started in the 80s. Mm-hmm. So in summer 1984, the first IP patent came up in the US by Bill Masters. And this is often seen as a birth of additive manufacturing. Then later on, the first industrial machines came into the game by Chase Hull. And then later on, Hans Lange in Germany formed his own company in 1989, which is EOS as of today. And others like Scott Crump invented in the 90s the filament-based production technology for additive manufacturing. So it's quite some time around in the world in different kind of materials. What is in common for all the different kind of areas, it's always produced layer by layer. So it's more like nature of growing parts instead of normally subtracting by milling, by forming, by grinding other classical methodologies.
Okay. Well, now, I'm surprised to hear that it's basically as old as I am. I mean, I was born in 81, so this technology has been around for quite a while now. Where do we stand today?
The difference today is the computing power and the software is so good that you now can start to industrialize it.
Okay.
Just imagine that computing power and digital material and digital technology gives you the full spread to really scale it and industrialize it. And we still see inventions in this area as of today. So if you would look in the world, you will find more than 100 industrial machine builder and even up to 200 if you count the smaller printer areas as well. They still invent year by year new technologies to make additive manufacturing really industrial grade ready.
Mm-hmm. So this is an ongoing process, obviously. And you just mentioned it's now basically possible to industrialize additive manufacturing. Give us some examples. What do you mean with that?
It all starts with the application. So you need to find the right application. One I have here, and I don't know if you see it, my shoes.
Yeah, they look like normal shoes at first sight, but the sole kind of does, stick out. What's with the sole?
It's actually a 3D printed sole at the shoe, and this is formed out of a function-driven lattice structure. And then you can manage to have a different kind of stiffness at the backside or at the front side of your shoe. This at the moment is still a design gimmick. But just imagine in the future that you go into a shoe shop and you scan your feet and then you upload this as a digital twin on a platform. Mm-hmm. So you would be able to purchase your individualized shoes, your individualized insoles in the future. And this is made possible by additive manufacturing. Check out a second example. Mm-hmm. And this is even much more complex. Just consider aerospace, automotive applications.
Now that looks like a pretty heavy part, to be honest.
And it's actually printed out of metal. And this is done in a project with a very complex structure for a much more flexible automotive part.
And what you're showing already is basically that you can 3D print out of all kinds of materials. I mean, you were talking about your shoe soles, which are obviously not made of metal. Now we have a metal part.
Definitely. This is ready to scale and to produce in large scale for much more flexible automotive production.
Now, it looks really complex, but if you say, like in your hypothesis from the beginning, in 10 years, additive manufacturing will be everywhere, is this really suitable for mass production, which is still a precondition for most industries, right?
Yes, definitely. So you can do both. You can do small-scale individualized products, mm-hmm. and then do it on production at economic scale. Mm-hmm. And you can do the same product every time, every day, and really produce at the same level of competitive costs. Mm-hmm. That's unique for additive manufacturing, since you need no tooling like injection molding technologies. However, you definitely will not kill and traditional manufacturing. You will augment traditional manufacturing by a full new area of technology with additive manufacturing, and this really offers new possibilities. Just take the journey how we started within Siemens more than 10 years ago. We started in our facility in Sweden mm-hmm. by repairing gas burner tips. So, and then later on, we invented and we learned that we can build the whole gas burner by additive manufacturing.
Now, on the one side, that's, of course, a certain area you're talking about here, the gas turbines, for example, and these big, massive parts. But there must be a different area also that you could mention.
I just mentioned individualization.
Right.
And just look into healthcare.
Right.
Healthcare is heavily investing and looking into additive manufacturing. Why? You have the ability to individualize parts at competitive costs. Mm-hmm. Just take orthesis. The purpose of every individual treatment by a healthcare or doctor is to really help you as a person to get restored your full person's mobility. And this is often a challenge because it takes a lot of time, and with casting, forming, milling and different kind of technologies, you are pretty limited in the manufacturing ability. And here, additive comes into the play.
Yeah, especially for highly individualized quality products like you just mentioned. And, I was thinking about this before we actually sat together here today. And I was wondering, how can you make it profitable on the one side, but also affordable for the end user, especially when we're talking about orthesis. Now, I spoke to Adrian Keppler from EOS, which is a German-based company specialized in optimizing additive tailored workflows, but also building machines to produce it. You want to hear what he said?
Yes.
Let's go for it.
Together with partners, we have developed an automated scan-to-print interface where you take data, scan data, for example, coming from a CT or another scanning device, let's say data from a leg or an arm, and automatically convert that into a print file, which the EOS polymer printer can process. After the printing of the orthesis, the part will be automatically depowdered. That means that you split the powder raw material, which can be reused, and the printed part. The orthesis itself will be post-processed, for example, cleaned and colored before you do the final quality assurance. This whole workflow, so from design to final product, is digital and it's highly automated. All relevant data are captured and can be used for quality assurance purposes or for further optimization. So let me summarize. It's not about cool parts which you can print. It's about compelling business cases. It's about developing a profitable business by leveraging the advantages of 3D printing in combination with other Industry 4.0 benefits.
Yeah, that was Adrian Keppler from EOS. And like you just said, I think, all these competencies from both sides basically come together, which make it very efficient. That's what I hear. What makes
Indeed.
it efficient, which again makes it profitable for the producers and also affordable for the users on the other side. But I'd like to jump back to the materials just really quickly here, because what are they actually? I mean, I can't imagine that you can simply replace a traditional, steel part with a 3D printed one. Is that possible?
Yeah, I already explained you about a lot of different materials by the parts I brought today.
Mm-hmm.
And it's steel, it's titanium, it's aluminium, it's polymers, a lot of different materials you can print. The only difference to the subtractive methodology is that you normally start with a kind of powder as a raw material in the process. And just imagine if you can digitally design a new material.
Wait a minute. Digital materials, how does that work?
Just assume you have steel. You can have a steel which is harder, a steel which is softer, a steel which is weathering, a steel which is magnetic. Normally, you can just have in a conventional part, you can have an either or, just one property. In Erlangen, we have one machine where you have combinations of powder you can now mix into the process. Mm-hmm. Just assume in a layer by layer process, you start at the beginning with a hardener steel, and then at the end, you change the composition. By that, you can make gradients in the part with different properties at the beginning or at the end of the part.
And it kind of sounds like you come up with new materials while you're at it, for me.
Sure.
Right?
Yeah.
So speaking of materials, let's look at another topic that's becoming more and more important to manufacturers. And that is, of course, resource efficiency and environmental efficiency. Now, how can additive manufacturing contribute to this?
Yeah, by nature, additive manufacturing is a resource-friendly technology. Because you glue only the powder together you need later on in the component. All the rest of the powder, like Adrian explained, gets recycled and then back into the process.
Right.
So it's very friendly in this kind. However, you need to look from any kind of application on the full life cycle process, from producing the powder till the service and the use of the part. I want to explain you 3 examples here.
Okay.
Normally, these bionic designed additive parts have 40 to 60% lower weight.
Oh, wow.
So at least you need less material to produce the actual part.
Just like the part you brought along with you, right?
Just the part I brought with me.
Right.
Secondly, then you use the part in an application, maybe in aerospace, maybe in automotive, in different applications. If you have less weight, you need less energy consumption in operation of the aircraft. So this is a big impact while you use the part. And third is in the sales or in the aftermarket for service. Just assume how many spare parts we have in logistics centers all around the globe, just waiting some time that there's a break in a product, that you can replace it. And now, if you print the part when you need it and where you need it, you save logistics, you save energy, and this is much more efficient than storing hundreds, millions of spare parts you don't need at the time.
Absolutely. So it affects the entire value chain, basically. Okay, understood. Now, one more question, though. What's your stake in all of this? I mean, is Siemens building industrial 3D printers right now?
No, actually not. We're not producing 3D printers. We're producing hardware components like drives, like controllers, which makes 3D printers more efficient. So the 3D printer companies are our customers in this regard. Besides that, we are developing software for designing, like I showed before, and simulating the properties and the functions of these 3D printed objects. So there, our aim is first-time right printing. Make it productive, efficient, and effective.
So you're basically partnering with 3D printer end users, but also with the builders.
That's right. And there, the word is co-creation, the technology with our partners.
Okay, and I think you brought a piece along with you to show how a partnership or what came out of that partnership. And that is a piece, ladies and gentlemen, I know you can't see it, but I'm going to try to describe this as a piece that looked like you just left it on the stove somehow. It looks like it's melted, and it's not supposed to look like that, but it is.
It's actually a part out of an HP printer.
Okay.
And just imagine a printer is as efficient as you cool the print head. And normally this is with turbulence and cooling behavior not optimized. And this fancy part here looks like this by purpose.
Right.
So actually it was not designed by an engineer, it was designed by our software, and the software optimized the full behavior of the part based on the optimized flow through this inlet into the printer. By that, you can improve the flow by 22%. What is the result?
Wow.
The printer can print faster. And that's how a 3D printer is enabled to be more efficient with a 3D printed part.
And we also spoke to one of our partners, with Phillip Jung from HP, who wanted to be with us today to explain how to collaborate in this field, but unfortunately he couldn't make it. But he left a voice message for us to provide some details, so let's tune into that.
Hi, this is Phillip Jung, and I lead the vertical markets and end-to-end solutions team for HP's 3D printing business. We're bringing together HP's unique 3D printing and data platform with Siemens' digital industrial offerings to make new industrial designs possible. And to demonstrate the power of the combined solution, we started with our own 3D printer, redesigning a duct system. Injection molding requires the manufacturing of 6 parts that are assembled into one duct. Using the power of HP 3D printing and Siemens software, we were able to redesign and manufacture this duct as one part, resulting in 30% lower cost and at the same time increase efficiency by more than 20%. Obviously, we're quite excited about it, and from now on, the printer is printing itself, so to say. And we're now going beyond this to take fluid management to other industries like automotive. Think about cooling system for batteries in electric vehicles, for example, and to bring new applications like lightweighting and energy absorption to the market. So think about innovative seat and shoe design that enhances performance.
So that was Phillip Jung from HP. Karsten, what are your comments on that?
I just want to add an invitation to you.
Okay.
So you're invited to Erlangen. In Erlangen, we have an Additive Manufacturing Experience Center.
All right.
And there, everything like Phillip and myself explained, we have live installed.
Well, hey, do you have coffee?
Sure, we have coffee as well.
Well, then I'll be there for sure. But I mean, besides the coffee, of course, the topic is interesting. Well, any new technology, as you just mentioned, also brings the need for new investments, right? So in times of economic volatility, that's not that easy, though, is it?
It always needs to have a thorough thought business case for additive manufacturing. It may be that you invest in your designer to make these fancy designs I just showed you. Then there are others in the industry having printers. They are looking for having others to use their capacity. Now take this additive manufacturing network. This really solves this issue. If you now combine the people who need parts, who design parts, with the people and the service provider who have capacity, and build a digital kind of distributed manufacturing network, everybody can work and collaborate with each other in a secure digital way.
And what do you think, to what extent is the industry actually using the potential of additive manufacturing right now?
If you listen to a lot of these reports from end of 2019, it's about 65% of the industrial companies are already using additive.
Is that a lot, or would you say?
I would say this is really a lot. It's broadly used in prototyping, 40%, but already are using additive designed products in small series. And this is growing and growing by the different industries. I would say aerospace is very well set and ahead of that. And then it comes energy, healthcare, automotive as industries heavily working and looking into the journey of additive manufacturing. And then last but not least, like my shoes, consumer goods. Just take helmets, just take glasses.
Right.
All these stuff you can individualize with additive manufacturing. This will come.
So thank you very much, Karsten. Looking at the time, unfortunately, our time has run out again, but I'd like to thank you very much for visiting us today. My applause to you.
Thank you for inviting me.
Anytime again. And many thanks, of course, to our listeners. I'm glad that you tuned in. And if you enjoyed the chat and want to learn more, please visit siemens.com/additive-manufacturing for more information. And of course, stay tuned for the next episode. This is Talking Digital Industries, and I hope you hear us again next time. Bye-bye.